Okay, next part. Fitting in an IEC power connector. And yeah, can't give you better angle. Anyway, I made a drill plan. And I will now mark the stuff out, hopefully without making any major errors. So my first line should be 6.1 millimeters. From the edge. And my second line at, what's that, 16.3. Okay. And now 11.75. Okay. So 11.75. That's in the middle of nowhere. Yeah, there will be a lot of filing involved. 16.25. Still filing involved. And 34.15. 34.15. Okay, just a second. Could be right, could be wrong. We'll see. So let's just center punch the holes and so I'm pre-drilling with 2 millimeters. This should be 1.6 and so it's more than 2. Okay, but I think I will file the rest, not so, you know, just to avoid that things get ugly. Okay, so we'll first try to file down here an edge which is exactly the inner edge to the edge of the case, 1.6 millimeters, which is exactly that step here, the depth of the step, and yeah, I'll let you know when I'm there. So yeah, my IEC connector is now fitting. I mean, not my best work, but yeah, I mean, look at that. Sorry. Yeah, try to fit that in somewhere. I want that flush with this edge. Okay. Just hold it there and oops. Mark the cut cutouts for the screws, the holes, cutout and holes. At the bottom it will be just a cutout, and at the top we will actually do another hole. Yeah, this was the old inlet. I said I would put the IEC connector on top, but yeah, that's not good. The fuse holders, the new fuse holder will go here. I also filed already the cutout for the lower screw. It's always good if you have also some small files for the small work. And now we're center punching the hole for the top screw. And we drill it. Wonderful. Okay, next stop, hole for the new screw, hole for the new fuse holder. Yeah, and I want to go the screw holder centered about the IEC connector. And yeah, there is another thing to consider it. Here on this side you can see it. There is a riveted nut on the side, and we need to stay clear of that one, I guess. But first for the center line, yeah, how do we do this best? Okay, we take the holes. The holes are, yeah, roughly yeah, 10 millimeters from the edge, and they were M3, weren't they? I think so, yeah. So if I do a line 1.5 millimeters from the edge above here, yeah, that looks good. Now the screw holder, the fuse, why I always say fuse holder? The fuse holder has a diameter of 12.4. That's another problem. I only have a 12 millimeter drill, so back to filing again, I guess. Just have to, yeah, ballpark the riveted nut that is in the side, not to interfere with it. Almost more the next error. To stay clear of that, I need, of course, the diameter of the nut, worst case diameter. And that's about, yeah, 16. Let's say 16. So there's the riveted nut. Maybe I do it from the top. It's not that easy. There's the riveted nut down here. That really right angle. Riveted nut, right angle. As I said, not that easy. Down here, and from there we go, did I say 16? Yeah, let's let's make it 17 millimeters up. And actually I don't need to go that far up. It's only half. Yeah, I'm pushing the center, so I only need half of the diameter, the radius. Okay, so 16 over 2 is 8. And for good measure, another millimeter. So it should go there. I think that was reasonable. Looking at it from the side. Yeah, that should be reasonable. So, center punch it. Trying to be really on the spot now. From both sides. Yeah, spot on. And for drilling, I think I fix the case in a little bit different way, so I have all the way sacrificial wood below the drilling hole, because now it's exactly halfway, and yeah, I feel uncomfortable drilling with 12 millimeters in there without proper support. Yeah, it's all a little bit on an odd angle, but yeah, it's already tight, almost too tight to get the drill properly aligned. And 12 millimeters. Yeah, that's the drill. Yeah, and now it's back to filing. Or maybe, just maybe, I take a bigger one for that hole, huh? Okay. Oh. Now I have to file with my left. Okay, almost done with the back. I will need another hole somewhere here to mount a classic bridge rectifier. But yeah, one addition, there's a little index here, because this fuse holder also has a little index, so it won't turn in the hole when you change a fuse. And yeah, let's pre-fit the stuff. Oh, I'll take you with me. and is not interfering with that riveted nut at all. Okay, I already knew that this would fit, but I need to find the screw to fix that. Just a second. Yeah, looks nice from the inside. Of course, one thing was to make sure that when filing in the little index that the contacts are probably aligned, not yeah, at 90 degrees, because then they might touch the case, and yeah, it would be tight with the cable. Next step, we should put in the transformer, because I need to drill new transformer holes. I think these were the old ones. Yep. And there's a fourth here. And this won't fit with the IEC connector and the new screw. Fuse holder, damn it. Running gag of this video. Yeah. A real transformer. So actually I don't need that much additional space, do I? Let's see. Yeah, let's make it back here. I would need about, don't go away, yeah, about what is that, 21 millimeters, and I measured that before. I had 9.5 millimeters in the beginning. So let me jot that down. So I need new 21 millimeters. That's a delta of 21 minus 9.5, 11.5 millimeters. Yeah, plus a little more space to get away from the mains connectors. Let's see. I can move these holes at most. Yeah, sorry, showing that here. I cannot put a hole to towards the transformer here. That would be mechanically unsafe. So I can move them safely at, let's say, 15 millimeters to the right. Wait, I changed the perspective for you a little bit. Oh, that's better. So I can need to move at least 11.5, but I could move, okay, that would be cutting into the material. If I move 15, so I moved 13. That gives me another 2 millimeters of space here. Let's see. be generous, let's move 14. Yeah, there's still enough material here to, yeah, at the edge of the screw hole to support it. Let's move 14 millimeters. And since the screw hole has a diameter of, it's a good question. Let's measure the screws that held the transformer. These are M4, I guess. Yeah, so I need 4 millimeter holes. So 14 minus 2 millimeters is 12 millimeters. Okay, and then we just mark that out without incident, hopefully. Okay. Yeah. 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 And now we just need some straight lines here. And I was actually thinking about moving the transformer a little bit to the front too. Because it's really hard to work here on the screws for the TO3 cases transistors, but unfortunately these nice big instruments, they have an adjustment screw right here in the upper left corner, and I'm not sure the transformer comes a little bit up. If I could reach that with a screwdriver when the transformer is yeah, that would be a little bit awkward. The transformer comes also a little bit more up. There are some distance holders which keep him up about, let's see, 50 millimeters. Do I have something that is 50 millimeters? No, sorry. I have to go hunt for something 50 millimeters so I can lift the transformer up and try that out. Turns out that the transformer standoff is more like 16 millimeters because I forgot to take into account the washers. And yeah, the best I can do is some wood that is 17 millimeters. But that should be okay. Just put the transformer on there. And let's see at which distance I'm still able to reach the adjustment screws. Yeah, there's a slight angle, but it's not that bad. The other thing to consider is the switch, which also gets quite deep into the case, but yeah. Yeah, that I think it's okay to put it a few millimeters to the front, hopefully. I mean, I don't want to go crazy. It was 21.5. 21.5 and 38.5 on the other side. Yeah. Do I risk it? And this would be hard to work on anyway, to get the connections in here, but we said we move it. Yeah, should be fine. If not, you hear loud swearing from me. Okay, put the transformer back into the box, out of the way. So all we need to do is find a nice line, and I take, as I said, it's only a few millimeters. I take the old holes and I go from the center of the holes 2 millimeters to the front. I'll take some other. The same on the other side. Yeah, and I'm doing it also on the other side from the same side, just to avoid any systematic error that if I now turn from left hand to right hand, my right hand for holding and drawing, I do something different, because otherwise the holes might not be. Yep, can probe that in the right spot. Okay, and now it's of course center punching time again, and yeah, doing this inside here is a little bit tricky. Yep. Yeah, securing your workpiece is still here. It's a clamp. The order of the day. So that's it for new holes for the transformer, and yeah, we have enough distance here to the ventilation slots. That's okay. And hopefully the power switch here at the front will not interfere. I just ballparked it, made no drawing this time, and yeah, I will clean up, pre-fit the transformer just temporarily to see where I can fit my bridge rectifier without interfering with the transformer, because I need that bridge rectifier to be exactly centered between the mounting holes for the TO3 transistors and their heat sinks, so can access it, because there's only a tiny gap between the heat sinks, and you don't want to disassemble your transistors each time you need to access the screw for the bridge rectifier, do you? Okay. Now that I have the new holes for the transformer, don't forget to deburr them. Yeah, I haven't showed the deburring. I use that thingy just with the hand. It's really one twist. Okay, time to pre-fit the transformer. The screws here, and basically the lower part with these washers, it goes to the outside, and oh, I put them all in and then I get back to you. Okay, the screws on the back, so each one gets one washer. That's actually fun, isn't it? One little piece of brass tubing to keep the distance. Yeah, that's fun. And on top of that, another washer, because, as I said, the holes in the transformer are a little bit, maybe 2 millimeters bigger than the screws. On this case, you can call them bolts. Now we have to hit all the holes. That was one side. And that was the other. And yeah, formally you have to use these washers on top, or at least they were installed, but I don't think that's necessary. It's just a pre-fit. Okay, so my power connector, yeah, oh, can't see it. The power connector, yeah, it's perfect fit. The power switch, I don't put it in the right way, but okay, you can see that either. And from this side, yeah, there's enough spacing to get the cables around and stuff. I mean, it won't protrude that much into the case, maybe a few millimeters less, so yeah, enough space. But the real question is, can I put the rectifier here? Yeah, it's a little bit tricky with the lighting at the moment, but we want that hole exactly here on the center line between the TO3 cases, because, as I said, there's only a very small gap between the heat sinks where I could access the screw. One way would to be drawing two diagonals, yeah, but and where they meet is the middle, but I think I just ballpark it with a ruler. Yeah, that's 100 millimeters in total, so we have should be fine at 5 centimeters. Where's my mark? Already lost it. There's my mark. And take a right. Take that up to here, where it will eventually go. Nobody will see that in the back, so not to worry about scratches. And I calculated with the distance from the top and the distance to the hole and the diameter of the hole, or the radius of the hole. I should go down 24 millimeters. 24 millimeters. So there. Center punch. Oh, the lighting is awful. Just give me a sec. There's an eerie effect if there's a lot of sunshine from the window, which is that direction coming in, and at the same time there we go. Okay. Secure your workpiece. Yeah, you know the drill. Wonderful. Almost. Because my goal is I will use a screw with a chamfered head, so that it will be flush with the surface, and therefore yeah, I need such a screw, and then I'll fit it in. Yeah, I remember, it's a countersink screw. Okay, countersink. So yeah, so let's countersink it. And I'm doing this by hand because doing this with a drill yeah, maybe I do it with the drill. Be very, very careful. And you really should use a drill press for this kind of work, but okay. The idea here is that the distance between, there's really only a small slot between the heat sinks, and the heat sinks have potential. Either the emitter or collector of the TO3 transistors, the cases of the TO3 transistors. And yeah, I want to avoid them shorting out when they get hit by something on a screw that's sticking out here on the case. Yeah, maybe I take the file to that to clean it up a little.